don't spend too much time of picking the best one. Just pick one and get some experience with how this loop works. I would not advise to spend 5 years on figuring out the best data collection strategy and then moving into the next step, because the value creation is only going to happen if somebody in the end does something differently. Then you're going to get value creation and the ROI that is really measurable, because that's going to improve your process within your factory. Things are moving incredibly fast, and if you're not catching up, you're sort of risking staying behind. For me, condition monitoring is very, very closely tied to predictive maintenance. Condition monitoring is about the health of the machinery. Is it healthy? Is it unhealthy? Pretty much the same applications of machine learning, with the difference that predictive maintenance really has that.
Okay, welcome to Industry 4.0 TV podcast. I'm your host, Kudzai Manditereza, and today we will discuss artificial intelligence use cases in manufacturing. And for that, I'm joined by Markus Guester, who's the founder and CEO of MontBlanc AI and the author of the book, Artificial Intelligence Will Revolutionize Manufacturing. Markus, welcome to the show. It's so much a pleasure to have you today.
Thank you so much for the invitation. It's great to be here.
Awesome. So maybe could you start by introducing yourself to the audience and tell us more about MontBlanc?
Absolutely. So, as already said, my name is Markus Guester. I'm actually originally from Germany, and I guess my first touch points in the manufacturing industry were, when I was kind of 15 years old, and I needed some money. And I was growing up in a small town somewhere in Germany, where I always try to joke a little bit, but they're pretty much more cows than people. So obviously there's a dairy factory there, right? So during the summers, I pretty much worked there, did sort of the simpler jobs because I didn't have any trainings or anything else. But I learned that like 15 years afterwards. But during that time, my head was always going on, man, this can be more automated. It can be more digitalized, right? It can be more Industry 4.0, AI, IoT, all those terms that I didn't know. It was just in my mind, just constantly thinking about those things. And then I had the chance to go to Boston to do my PhD at MIT, and was doing a lot of sort of machine learning, AI research in a slightly different industry, but still always focused about how can we leverage data to make better predictions, to make better insights. And then kind of 15 years afterwards, I went back to that same factory, and for some reason kind of was shocked. And that's not it's pretty much average, above average, modernized factory, right? This is not like some whole, it's really, really good stuff. But I realized just the delta that exists between 15 years ago, having these thinkings going on, doing fancy research, doing all the modern stuff, publishing papers about this is 5% better than this, and then going into the factory and realizing, well, not a lot has changed. Like the gap kind of seems to widen and widen and widen and widen. And well, that was really for me the reason to start together with a bunch of other people, MontBlanc AI, where we're trying to bring AI driven or just smart working solutions into the manufacturing industry, and trying to close that gap a little bit more.
Awesome, interesting. And it's really interesting to know kind of like your journey, because I also, getting into this space, I share some of the realizations that you had when I first went into a factory, just kind of like seeing everything being done manually, paper based. It was very clear to me at that point that this is an industry that is ripe for change anytime. And that's kind of like the moment I started to kind of like investigate this whole stuff. And like you, I didn't kind of like have these terms, Industry 4.0, industrial IoT. It was just kind of like clear to me that this is going to be digitalized. There's a way of coming here, and this is how I got into this space. And it's interesting how far we've come now, and we're at a point where, again, as you sort of like put out a book about how you see how AI is going to revolutionize manufacturing. So in your experience or in your perspective, which areas of manufacturing have you seen the biggest potential of being impacted by AI?
Yeah, I think it really probably depends on the type of manufacturing and also the size of the companies. I think the really low-hanging fruits are really in sort of marketing, content creation, sales, etc. Where really AI, generative AI, just picked up a lot over the last sort of 1-2 years. That whole concept about co-pilots for all the sales to marketing tools that you have. But we're sort of refocusing MontBlanc AI is really the operational aspects and the part of AI. So you have AI, is gigantic buzzword, which right now most people use for ChatGPT, but there is so much more to AI. And when we talk about AI at MontBlanc AI, we mostly talk about machine learning. So really the part of AI that crunches numbers, that crunches big numbers for you, and then makes prediction about certain outcomes, which then enables those use cases about predictive maintenance, figuring out if there's any issues in your process, just automatically understanding how your factory usually runs and detecting those bottlenecks where there are issues. So this is where I personally, and sort of as part of the company, it's our strategy, but we really think there is the biggest leverage, because there's just you're relying on numbers, on data that is constantly gathered, and you're making really solid predictions about that.
Awesome. I mean, let's kind of like dive a little bit deep into these use cases to explore exactly how sort of like they work. And you mentioned predictive maintenance, which is often cited as one of the lowest hanging fruits or the most beneficial applications of AI in manufacturing, as you have just alluded to. So can you kind of like explain to us in detail how AI can predict equipment failures, and what are the implications of industry-wide adoption?
Yeah, absolutely. And I was thinking about this along how to explain that in my book. And the analogy that I came up, and let's see how that resonates here. But I had an old car in Germany, and how old cars, they're always making noises, some sort of noises. And at some point, you're pretty much getting used to noises, to the vibrations that the car is making. And if you have kind of frequent friends joining you on a car ride, they will also get used to this. And then there are some other points where you pick up some new friends, and they're in the car, and then they ask you the question, is this car right? That sounds a little bit odd. And for me, this is pretty much what machine learning in AI is doing for predictive maintenance applications. Because what's really happening is that your machinery is making some sort of vibration, some sort of noises. It's never perfect, right? There's always something coming out of this. And it depends on the environment. It depends on how old the machinery is. It depends on what is currently doing, what's the load. So what machine learning is extremely good at is just to learn what is a normal behavior. And this is what, in the car, I kind of intuitively just understood, okay, no, this is normal, right? This is a normal behavior of the car, so that's normal. And if there's something that's really out of the ordinary, like one time from my car, the exhaust fell off, right? You immediately hear it. You immediately hear this is something out of the ordinary. And this is where machine learning really comes in, because it can automatically self-tune, and it can automatically just understand, okay, this is normal and this is out of the ordinary, and then sort of make really predictions about that. Because some of the, if you look at it in a sort of different way how you would do it without machine learning is really you have to define harder thresholds. If this noise level is above this, if the vibration is above that certain threshold, then you send out alarms, and then you get a lot of what's called false positives. And false positives are probably the most frustrating and sort of user experience killing thing that you can have, because it basically says false positive. So you send an alarm and it's incorrect, right? You're raising a flag, you're having a lot of red lights, but there's actually not an issue with this. And then very, very quickly, you will just lose trust in that system that is producing those alarms. That's why a lot of those threshold-based approaches don't really work, because they're only sort of two extremes. On one extreme, you set the threshold pretty tight, then you get a lot of false positives, and then what automatically happens is that everybody is increasing those thresholds, and then you're just missing it, because then you're just saying the threshold's very, very high in order to not get any false alarms. And this is the really sort of prime use case for machine learning. That's why predictive maintenance, really that whole topic is I think, if you want to pick one use case in sort of the industry 4.0 area, it's the one that's the most understood, where you can sort of the easiest really get quick value, because just out of the simplicity that it works.
Okay, so maybe just to kind of like linger on that a bit and maybe get a bit technical, what sort of machine learning would that be? Is it supervised or unsupervised? And the reason why I ask is to say, would you need to get data about that machine, because a lot of manufacturers may not already have connections to the machines to get this data. What are the steps? What is the workflow? How does that look like to be able to implement predictive maintenance?
Yeah, so certainly in the workflow, I think that there are probably two different sets of solutions to that, and two different sets of companies that are offering predictive maintenance solutions. One set of companies is that they're really targeting, I would say, more the unconnected machinery. They bring a sensor with them. They bring the sensor, they attach it to the equipment. That equipment then, that sensor then starts recording the data completely autonomously, and it's not connected to anything else of sort of within a company network. So that's sort of one set of solutions. The other set of solutions where MontBlanc AI is, we are mostly relying on actually having connected machinery that is producing some sort of data. It doesn't need to be exactly the vibration data of the machinery. It can be any sort of data, and we infer a lot of from the existing signals already. The way we really approach the sort of detection process, and where we also have a patent on, is to start unsupervised learning as much as we possibly can. Just to quickly, say what's unsupervised versus supervised. In supervised learning, you basically you show the machine learning pictures of cats and dogs, and you need to label them, right? There's a human effort required to say this is good, this is bad, this is good, this is bad. In unsupervised learning, the machine learning tries to just listen to the data and figures out automatically, okay, this is one category of things, this is another pattern, this is another pattern. And there's this gigantic advantage that you don't need to label data. So in our approach, what we do unsupervised learning as much as we can to get to a really good threshold, and then starting to detect things, and then we go into supervised learning and further improve the detection process. And that has the big advantage that our customers already get value out of the system before they actually need to start labeling the data, because the labeling process is always the most time consuming and honestly sort of the biggest break for a lot of the AI applications that are out there. So we are basically offloading that towards the end. already giving them really good recommendations, and then when they sort of further give us feedback, the machine learning just improves over time and becomes better and better.
Awesome, great stuff. Yeah, so to move on to another use case, which is quality control, which again, quality control has always been a cornerstone of manufacturing, in ensuring like the that product meet certain standard before they are shipped to customers. And with the rise of AI, we're seeing some exciting changes in how these quality control processes are being managed. So I'm curious to hear your thoughts on how you see AI being used to enhance quality control in manufacturing. What trends are you seeing in this area?
Yeah, I think one trend is certainly visual inspection. And I think if you look at the Gartner hype cycle, we are probably on like the stabilizing path of that technology. It's been out there for quite some time. AI is just great at sort of visual recognition pictures. You train it on a few things, and it's really good on detecting any sort of quality issues. So the way that use case works, whatever you're producing, whatever parts you're producing, you basically have a camera on it. It takes constant pictures and it compares it to an ideal golden part. And then if it detects any issues, it basically just notifies and stops the production there, or puts the part into a sort of a separate process. So I think that technology is pretty mature. There's a lot of solutions out there. They're pretty easy to set up. They're sort of also run pretty standalone, so it doesn't require a lot of integration efforts. The other sort of set of quality control, and that might be more in the sort of process oriented industries, and there we are much more looking at a similar approach to determining what's normal and what's not normal, but more based on process parameters. So the quality of let's take the dairy industry for an example of a specific product is mostly driven by how it's being processed throughout many steps, and the processing, of course, is never exactly the same. So you always have some variation of temperature, mixing ratios, speeds, pressure levels, etc. But you want to make sure that this is in a certain boundary. And again, having hard thresholds there will not really work, will not really scale. So again, machine learning comes in to basically learn now not how your equipment normally sounds, but how is actually a process on a normal level, and therefore enable you the quality control aspect, because now you're not necessarily checking the health of the machine, but really the health of the product that you're producing in a way. And the health of product is kind of the quality in the end. So this is kind of I would say the live detection part of quality control. The other trend that we're really seeing is in an industry that's very sort of highly regulated, where you need to be able to track and trace back the issues that you're encountering, and there it's really important that your quality control systems are capturing that information. That's a big advantage of either if you do it visually or through process parameters or anyhow. But that's sort of one of the advantages versus having somebody experienced sitting there and observing the things, that you actually have a record of what you produced, and you can always go back and say, well, what did we miss, right? Because nothing is ever perfect, but you want to be steadily improving over time.
And I'd like to get a sense of how much of a domain expert involvement from companies do you kind of like leverage in kind of like building out these quality monitoring, quality control, even including predictive maintenance? Is it how exactly does it work? Is there a certain amount of domain expertise that you need to kind of like bring into the picture? How do you work with companies typically?
Yeah, there's certainly, especially in the early stages, I think, where we are still in AI, there's a lot of domain knowledge required from the customer perspective. Ideally, our vision is that we capture a lot of that domain knowledge, that we really just say, okay, we got a lot of feedback about that specific equipment. We got a lot of feedback about that specific process. The AI learned by itself that this is now, it captured some of the domain knowledge, right? It captured some of the domain knowledge, which we hear a lot from our customers. There's a lot of issues with high turnover. It's getting harder and harder to find really sort of the right people that just have the right mindset and the right skill set. So we want to certainly empower the workers that they have right now in order to also capture some of that domain knowledge and give that domain knowledge back to them.
Awesome. So another use case that we often hear about is AI-driven process optimization. Could you maybe help us here, shed some light by breaking it down for us? How exactly does AI-driven process optimization work in manufacturing, and do you have any examples of, say, companies that are using these methods?
Yeah, I think sort of when we talk about optimizing, that's for me at the more towards the future of AI. So in my book, and I can try to show that here a little bit. I'm talking through basically 4 steps here. The first step is collecting data, otherwise none of the AI will work. Then communicating data, then predicting and detecting, and the last step is then recommending and acting. And if we talk about a fully automated control flow, right, there will be sort of in the recommending and acting part. And this is what I think is sort of the final evolution stage of AI optimization of a process, where it collects the data, it analyzes it and predicts, and then also takes action and recommendations immediately and sort of optimizes it itself in the production process. That's obviously, I think, a scenario that at some point we will get to. But what I see is that already in the very beginning, when you have it collected, when you have it visualized it in the right way for the right people, and that's very, very critical, then the humans will do the optimization. And that's I still think that is AI powered optimization to some degree. The next step would be that the AI is really analyzing and giving a more concrete actions and recommendations, and the human is then implementing it. So I think those are sort of the different phases that we will go through, where the human, until the foreseeable future, for really the rather more advanced or complex processes, will always do the final execution and the final check. AI can always be there as a sort of support and saying, yes, this is what I would recommend. Here is why. This is why it would improve. Why don't you sort of try it and then reassess again? So I think this is a really, really critical loop to make sure that the AI human interaction is going well in that sort of optimization process. I've seen it on smaller scales. So if it's really more like a control loop, right, that's running on a PLC sensor level, then AI for sure can help. But we have to keep in mind, AI is not a 100% accurate solution, right?
Yeah.
Many people believe it, but it's just not. It will always make mistakes. So the further you go down towards PLC control level, the really more careful you have to be. And maybe it's just better to not use an AI technology and go more with sort of classic control theory.
Oh yes, I mean, I was about to ask that question to say, is it a technique? Is it a case of a technical challenge, or rather that where AI systems are not yet mature enough for this kind of optimization, where they're able to close the loop by themselves? Why would we need a human in the middle, in currently? Is it because it is technically challenging to close the loop with AI, or is it just a matter of saying we don't trust it enough yet at this stage?
Yeah, in my personal view, it's we don't trust it enough yet. I think we are in a really, really hype cycle of AI. I've been doing AI for the last 10 years or so. So I've been there before, and I've seen how it just hyped up completely. And I think everybody's expectations are super, super high. Like we're constantly approached with problems that AI is just not the right fit. And that happens a lot right now. I think over time, we will slowly figure out where AI can work, what are the limitations. I mean, by now, I think everybody figured out what the limitations are of ChatGPT, and so will we do with all the AI tools that are out there. So AI will evolve for sure. It will become better and better, but it's not going to be the answer to all the problems in this world. And I think one of the problems that is probably not the best use case for AI is really to have a complete automatic control loop in there. I think AI is great to support the humans, to support the decision maker, but to have a fully closed control loop, that there's better technology out there. And one thing that also, you talk a lot about OT and IT convergence, and AI usually plays in the IT world. So now if we're closing back the loop to the OT world, that's also kind of a dangerous path to go on.
Okay, now moving on to condition monitoring. So first of all, could you sort of like explain to us when we talk about condition monitoring, what are we talking about? And then can you walk us through how AI is being used to enhance condition monitoring and also production monitoring?
Yeah, I will separate out those two, and I have to say in advance, these are all buzzwords, right, that are generally ill-defined, and that's a gigantic problem in, I think, the Industry 4.0 sort of space. I actually tried to, I don't know, when I wrote this book on AI for manufacturing, I did a lot of research and tried to figure out what are good terms, what are the key use cases, how is everybody talking about, like what are the definitions, right? It's sort of a research background. That's the first thing they try to do. And I looked through a lot of stuff and created this word cloud, and it's with a quick look at it, you realize, well, it's all over the place. Everybody uses something else. There are brand names out there. So that just being taken on sort of the precursor of the question. But okay, condition monitoring. For me, condition monitoring is very, very closely tied to predictive maintenance. Condition monitoring is about the health of the machinery. Is it healthy? Is it unhealthy? Pretty much the same applications of machine learning, with the difference that predictive maintenance really has that specific aspect of being predictive about it. You want to predict it fails in 3 weeks, it fails in 5 weeks, it fails in 2 months or so. Condition monitoring, it's really more giving your current state. Is it healthy? It's slowly degrading. It's unhealthy. That's how I would differentiate those two. And condition monitoring also can have multiple root causes. So if something is unhealthy, it doesn't necessarily need to be a maintenance issue. It could also just be an issue that the environment conditions are not incorrect, or the machine is wrongly configured or something else. So the root causes can be different. Usually you first identify the condition as sort of being unhealthy, and then you go another step and saying, what is actually the root cause of this? If the root cause is, okay, maintenance is required, then you go into kind of predictive maintenance and say, yes, in 3 weeks, 5 weeks, 10 weeks, part A or B has to be exchanged. That's the differentiation for me. Then the other use case that you mentioned is production monitoring, which is kind of an extension of OEE monitoring, but really to a deeper and broader extent. OEE basically gives you some uptime figures, some downtime figures, but production monitoring is really live right now, and it encompasses a lot of the other use cases. It encompasses, okay, condition monitoring of the machinery. Are they healthy? Are they unhealthy? Do they need maintenance? It encompasses the process and quality control. Are my processes running within scope? out of scope? Is there any issues? It encompasses the environmental condition. Is my humidity within the factory correct, incorrect? Is it out of the ordinary? What's the outside temperature, right? It gives you kind of a holistic view of what is going on within your factory, and usually also targeted more towards the upper management or the VP of operation, plant manager, sort of on that level. Right, this is giving you the bird's eye view, and then some of the other use cases are really more targeted for different departments. The maintenance department is much more interested in predictive maintenance use cases, versus the quality assurance sort of department is much more into RMAP processes running in control. How was my CIP cleaning? How was the cleaning? And then maybe some general maintenance is more interested into the environment. So that's how I like to think about those different use cases.
Oh, I see. So, I mean, well, what I'm understanding is that production monitoring is kind of like it encompasses almost everything that's related to. So it's sort of like a grouping of use cases, of AI use cases, right? And does it make it a use case on its own? So it's not a use case on its own, but rather a grouping of use cases. Did I get that correct?
I think that's probably the right way to put it. Yeah.
Okay, perfect. All right, maybe kind of like in relation to production monitoring and condition monitoring, let's focus on MontBlanc AI solutions. Could you kind of like explain to us sort of like what sort of can you maybe explain to us about MontBlanc solution as part of the tooling? What are the tools that are available? How do they work? How do they help manufacturers spot and address issues before they become bigger problems? Can you kind of like give us an introduction into MontBlanc platform?
So basically, what we are really covering is the main use case is the grouping, right? Production monitoring. So the history of the company is really based on the research that we did at MIT, where we sort of looked at some core machine learning algorithms that pretty much do exactly what I described before: learn the normal behavior in an unsupervised way and detecting outliers from that. And that's really the foundation of how we started the company. That's sort of our core IP knowledge of the product. What we've done so far is really building the things around it, right? Because in machine learning and AI, the research is 100% on the core stuff. Once you start building a product and trying to bridge that gap, right, and the bridge is widening, then the most important things are the 95% or the 99% that's surrounding it, because people have to interact, they have to visualize it, etc. So we've been very much focusing on building that piece around it, with always the guidance in mind that it has to be very easy to use. So we want everybody within the factory to have the same lens and be able to use the tool with very little training required, that it's easy to set up, take the friction as much as we possibly can out of the setup process, the data ingestion process, all of these aspects, and then also make it integrated into the system. Because the thing that we want to avoid is just have another standalone solution that's doing something and is not integrated into the bigger context. Because if we talk about the bigger use cases, production monitoring, right, you want to get an overview about everything. And one of the big issues that we saw very early on, that there are so many silos of disconnected systems, and it's one of the key challenges. So we didn't want to contribute that. We actually wanted to do the opposite, of being very open to integrating into all sort of other systems. And this is also where down the road AI becomes more and more powerful, because it gets more and more context, and then you need sort of less labeling, less supervision work. It's unsupervised learning is going to work a lot better, because you just get much more context from all the surrounding systems as well. So that's sort of our general vision and strategy. So what does the platform actually do? We are very data driven, so we integrate with a variety of different connectors. We can go all the way down to having software solutions that integrate with on a PLC level. We work on OPC level. We work on MQTT level. We have multiple different entry points into our platform. And then what our platform basically does, it's ingesting all the data. It's organizing, it's cleaning it, it's doing also the pre-processing step. Then it is visualizing it in a variety of different ways. It's exposing that to APIs, so customers can use their own visualization platforms if they would choose so. And then on the background is really the core and the uniqueness is where we run all of those detection techniques on the data sets, constantly train our machine learning models, and then send out notifications and interact with the user to make, on one side, their processes better, and on the other side also their recommendations better as the machine learning becomes smarter and smarter. So we're really sort of a plug and play, no code, easy solution that small to medium enterprises can just plug in. The starting cost is really low. We go all the way down to the PLC level, but we also have the scale and the complexity management and API for bigger enterprises as well as to sort of grow.
Just to linger on that a bit, who would you say is most sort of like suitable user for your platform? Is it the OT engineer? Is it the IT engineer? Is it a data scientist, or really anyone kind of like who knows what they want to do can be able to use your platform?
Yeah, so we are really on the end user, on the operation. So our typical users are really from plant manager, VP of operation, having that bird's eye view, down to the people on the shop floor that want to understand how was I actually doing over the last couple of shifts, right? What happened the shifts before, down to, of course, then the team level and all the levels in between, all within the operational departments, also in quality assurance departments, right? As I mentioned, sort of that batch and trace functionality, but we see a lot more coming up, where they just take the product, they have a specific code in the product, can be expiration date, article number, whatever, just put it into our search bar. Within 10 seconds, they will get spit out, okay, this is how it was running. There you look, maybe you have to do like a root cause analysis. Here are a couple of pointers of things that we saw that kind of didn't really work well, and that's bringing really the root cause analysis down from impossible, maybe weeks, maybe days, into now seconds, and that's a real game changer for them.
Awesome. So yeah, I mean, you earlier on you brought this idea of the power of kind of like having an open ecosystem where different applications can plug into each other and not kind of like exist as silos, which is really what we're trying to run away from, and which I agree with, by the way. And just kind of like from the context of your AI, to be able to get that context from many different sources, and also just from the ability of being to operationalize like the insights that you are then able to generate for you to be able to kind of like pass those on to other systems. So curious to find out, I mean, you already mentioned that you have got integration mechanisms such as MQTT or PCUA. Would you like to speak about how like broadly MontBlanc sort of like integrates with other systems, both in the OT and IoT domain? Maybe if you wanna tell us about a few systems that you integrate with.
Yeah, absolutely. I think on the sort of, we divide between upstream and downstream. So upstream is really where we gather the data, and that's commonly SCADA servers, OPC-UA, MQTT. That's coming sort of from the OT level or the slight level above. And then we, on the other side, have downstream systems, and that's typically ERP systems, CMMS systems, so wherever there's sort of maintenance management going on, and then also in some cases LIMS systems, so for laboratory results as well. And the way we typically integrate it is we, like an example from ERP system integration is really that we are pumping data into the ERP. So we have from an ERP system, it flows down through MES. You get an order for I don't know, let's say 5,000 parts of product A. So it flows down into your production line, right? They're going to be produced over multiple steps. And then what we push back is basically, you produced actually 4,998. 5 of them had an issue, and we detected a slight anomaly within a specific stamping step that was part of this process, right? These are kind of information that we're pushing back into, for example, the ERP system, about specific orders and parts and sort of batches that were flowing through the production line. Another things that we're pushing back is things like energy consumption. How much energy do you actually consume while producing that order? How much downtime was part of this? Like how often did your machines stop in between? Sort of just general aggregation information of the data that we anyway have in our system. So this is mostly the ERP part of the integration. What we do with the CMMS systems, the maintenance system, that's really pretty much the predictive maintenance use case, right? Or condition monitoring. If we say there's something unhealthy, need maintenance in 3 weeks, then that's pretty much something we push into the maintenance systems and say, hey, there's a maintenance in 3 weeks. And then sort of all the scheduling, all the vendor management, everything is done in the CMMS system as well. And then very similar to the other system that I mentioned, which was the more laboratory results for quality control. And that's mostly for sort of in the process industry, specifically talking about, for example, the dairy industry, there's a lot of cleaning in place. So this is quality data that needs to be pushed back into, for example, the LIMS system, and says, well, the cleaning of that particular equipment, that tank wasn't quite as good as it maybe was before. So these are sort of the results that we are pushing back into these systems.
Earlier on, you touched a bit on generative AI. So first of all, I want to find out, do you also offer generative AI services on your platform? And secondly, how do you see sort of like generative AI shaping the future of manufacturing? What sort of transformations might we expect in the coming years from generative AI?
Yeah. The way we think about generative AI is really enabling everyone to become a data scientist without being one. Right? This is how we think about AI, generative AI within our platform. Because what generative AI basically does, it abstracts data and wraps it into text that everybody speaks. So these are use cases like you see co-pilots popping up on every possible platform that there's out there. We use it within our platform right now for two areas. One is about the anomaly detection part, where we really collect the user feedback and gather that all together. So basically transforming text into data that we understand. And on the other side is doing the opposite process, where is one example, OEE reports, sending them out on a scheduled basis, on a daily, weekly basis, and summarizing just the key points, right? This is where the AI is really analyzing the data, and you have who knows how many equipments with who knows how many up and downtime reports. And on a weekly basis, you don't want to get just a whole list, right? You want to get what's interesting for you in a textual way. And this is where we use generative AI to basically analyze the data, put it into reports, and send it out at the right time to the user. For us, where this is going, basically really expanding on that use case a lot more, and allowing the user to just have a separate way of interacting with our platform. The main interaction with most of the tools today are basically through user interfaces, right? You build a user interface for all different types of things. You build visualizations, you build dashboards, but you cannot build endless amount of dashboards for every possible use case. So what we want to do is to enable them a second channel to interact with our platform, and that's just through text or voice, or maybe at some point video calls, who knows, but probably mostly through text and speech, as well as pictures, right? We can imagine somebody taking pictures of certain equipment and saying, hey, when was the last maintenance, and then we can just search in the database. Generative AI is pushing it back to that. So that's how we think about just giving them a second access channel to the underlying foundational data layer that already exists.
Now, I mean, it's whether you're doing generative AI or predictive maintenance and all that, it's no longer really a secret for people out there that data is kind of like at the center of everything when you start talking about AI. But it's still challenging to get the right data. I'm sure you'd agree with me that you really need to have that right data for most of the AI use cases, both in terms of quality and kind of like the context of integration, and which can be a big challenge. So, what are some of the common obstacles that you see manufacturers facing when it comes to data quality and integration, and how can you sort of like advise them to overcome these issues?
Yeah, that's a really core point, I think, to everything. I think the really good thing is people understand that without data there's no AI. So it got a lot more attention over the last couple of years. What I think we realized in the manufacturing industry that actually the data quality is generally really high, and also data collection availability, or data availability on the PLCs and on the machinery is generally high. What's not there is a common aggregation. It's a common aggregation. It's putting all those pieces together. We hear a lot of customers when we're talking to them, it's like, no, we don't have that data. We don't have enough data, etc., etc. And then we ask in the question, well, do you have a PLC that measures the temperatures and does its control loop and adjusting things, right? And then the answer is, yeah, we have that. And then the issue is really that the data is actually there. It's sitting somewhere, but it's just this connection layer that is completely missing in here. And this is where there still needs to be a lot more work being done in order to extract it. But there are a lot of really smart companies out there that are working on just providing these connection pieces and putting them together into one place. So when we talk about data quality, I think parts of it is also, do we have sort of a unified language to talk, or a unified data model? Because one part is, can those things actually talk together? So what is the authentication, the protocol? Do they talk with MQTT or OPC UA or TCP or whatever the protocol is with each other? So data comes from one end to the other. That's one part of the equation. But the other part of the equation is also that the data comes across. Is it somehow normalizable across a variety of different systems? Because at the end of the day, if you have a common platform and you want to have sort of this unified lens, you want to avoid data silos, it has to be some sort of pretty standardized, normalized data model, because otherwise your AI is going to be super confused. You cannot visualize anything, and then you just end up with not really a platform, but a platform that you customize for every manufacturer in its smallest details. There needs to be some customization, 100%, but the most important thing is that we really find a way to normalize that data from the specific format that the different equipment is sending it into something that actually that the platform's understanding.
From our conversation today, it's clear that AI is becoming a game changer in manufacturing. However, for companies that are just starting to explore its potential, it can be a bit overwhelming. So, for any manufacturing company that is new to AI, where would you recommend they begin? What are the first steps they should start in kind of like integrating AI into their operations?
Yeah, for me, there is a misconception that has to be solved a little bit, and that misconception is AI equals complex equals expensive, and that is actually not true. That is really not true. AI will make it a lot simpler to do a lot more things a lot cheaper. That's the way to think about it. What specifically that means for your factory or your manufacturing site or your machinery, this is still something that the whole industry is working on, right? To define exactly what is always the starting point. Until we get to that point, my recommendation is always to just get started, because things are moving incredibly fast, and if you're not catching up, you're sort of risking staying behind. Where to get started? I would say get started on a single end-to-end use case. And what I mean with end-to-end is going all the way from data collection, if it doesn't exist, to visualization, to predicting, and recommending. So doing that whole flow, including the human in the loop that also takes the action, that it improves the process, because otherwise you're never going to be able to measure any ROI at the end. But pick one, and don't spend too much time of picking the best one. Just pick one and get some experience with how this loop works. I would not advise to spend 5 years on figuring out the best data collection strategy and then moving into the next step, because the value creation is only going to happen if somebody in the end does something differently. Then you're going to get value creation and the ROI that is really measurable, because that's going to improve your process within your factory. That's not being said that once you gather some experience with maybe 1 or 2 use cases, then you certainly have to go into like a proper architecture of your data collection. How are you going to store that? You really have to deeply think about that, because that's absolutely crucial. But in order to get started, my recommendation is get started, do the pragmatic approach, find some partners to go along that have a platform that you can just easily try out and see how it really works for you. Because parts of the thing besides the ROI that will come out in the end is also learning, especially in the beginning, and that in my view should be the focus. You need to learn what AI can do and what it cannot do. And the last point is actually more important. You should figure out what AI cannot do, because that will set you up a lot better into any sort of future vendor selections and talks what makes sense for you and what doesn't.
100% agree with you regarding the last point, where it's super important to start to kind of like build that AI fluency, as it were, kind of like early on as you navigate the space. Because I've heard some argue that we kind of like don't need to jump all in, just wait for the technology to be mature. But by the time you kind of like decide to do that, competition is already kind of like miles ahead, and they already know how to work with these systems. Because especially in manufacturing, we as you alluded to earlier on in the beginning of this talk, where we are not used to using data to make decisions, right? It's more of gut driven. So to kind of like change that culture into where you sort of like using it data driven, you need to start working with these kinds of systems. So I totally agree with you there. So, I mean, you spoke about the idea kind of like of this unified, the need of a unified data system in manufacturing, where AI can kind of like provide real-time insights across different systems. So, kind of like want to get your elaboration on how MontBlanc AI is working towards making that a reality.
Yeah. What we really striving for is not to reinvent the wheel, right? And not to make our differentiation in the market by defining our unique protocol that nobody else speaks and blocking everybody else out, right? This is not our approach. We always first try to integrate, find something on the market, find partners that we can build that ecosystem together. Because to be honest with you, and I think we're all in the same boat, right? There are some competitors, there are some other players out there, but if we look at the overall market size, I think we're still not enough, right? So I think there's no need to put your elbows out and say like, no, I'm gonna have this data format and nobody gonna talk to me. I think this is the absolutely wrong approach to that. So our goal is to really be open and rather integrate than develop in-house.
Awesome. And then briefly, the other topic that I wanted to talk to you about is this idea of security and regulatory, because it's bound to be one of the things that manufacturers are thinking about a lot as they explore the application of bringing AI into their sort of like environment. So what are some of the key considerations that manufacturers should keep in mind when it comes to data security and regulatory compliance as they adopt AI solutions?
Yeah, it's absolutely crucial. All the platforms that are out there, they use something else behind the scenes, right? It might be a cloud, it's running on some cloud platform of Microsoft, Google, or Amazon, or somewhere else. If there is any generative AI feature as part of the platform, it's either going to run on Microsoft OpenAI, on OpenAI service, or some of the competitors, right? So there's always going to be something running behind. Probably almost no platform that is out there today has their own OpenAI equivalent model running on their own platform, right? That's not happening. So this is something to really be aware of, and look deeply into what's also running behind the scenes. What type of data privacy and protections do they have in place? GDPR for European is absolutely crucial, and probably something similar will come to the US too. I think one thing that's really important to understand in security, and that sound maybe counterintuitive, is nothing is ever 100% secure, right? I use this analogy of how many locks do you have on your door? One, probably, right? Maybe a second. Why not have 3, 4, or 5 locks, right? Like, how many locks do you have? And it's very crucial to find that balance of having something absolutely secure. It's very critical, 100%. And what is the data that is flowing into these systems? If it's very personal data, very sort of personal data to your manufacturing processes that if gets out will completely destroy you, you have to pay incredible attention to this. If it's some data that if it gets out, maybe it's less sort of critical than personal bank accounts going out, then you have to apply different levels of security to that, because increasing security always comes with of course more friction, higher costs, and everything else. So there's going to be a balance. The way to think about data privacy and protection, except of having standards and sort of the basic stuff that every company that you work with should just basically have. The rest of it is really coming on a scale.
It's been such a wonderful conversation that I've had with you here today, Markus. Fortunately, we've run out of time. So that brings us to the end of this conversation. Thank you so much for coming through to the show. Do you have any last words for our audience? Anything that you want to talk to them about? Of course, we will provide a link to your book in the description below. We're also going to provide links to your website and also your social media accounts. So any last words for our audience?
It's been an absolute pleasure to be here and spend an hour talking about what we all are really passionate about. I think my final word is just get started, right? That's for me my just final word. Get started. Dip your feet into the water.